Hey everyone, thanks for tuning back into our channel. If you're loving our content, give us a thumbs up and hit that subscribe button. Stay tuned for more awesome tutorials and reviews. Let's look at how you can convert text to music. How can you use an AI model called as Refusion to convert text to audio? If you are new here, and if you like my content, please subscribe to the channel. Let's get started. So this work came up somewhere in the last week of December, so this is called as Refusion. That is Stable Diffusion, which is the open source AI which can generate images from text. So what they have done is that given a text caption, they have fine-tuned the Stable Diffusion AI to generate images of spectrograms. Okay, now what are spectrograms? So spectrograms are nothing but a way of representing audio. Okay, so audio spectrogram is a visual way to represent the frequency content of a sound clip. So the x-axis over here represents time. The y-axis represents frequency, the color of each pixel. In this image gives the amplitude of the audio at the frequency and time given by its row and column. Okay, so the amplitude is this, okay. So the color over here for each pixel is the amplitude of the particular frequency. So in this way you can represent an audio. Okay, so this can be computed from an audio. The spectrogram can be computed from the audio using short time Fourier transform. Okay, which approximates the audio as a combination of sine A waves of varying amplitude and phases. So this particular Fourier transform is invertible. So the original audio can be reconstructed from a spectrogram. Okay, so in this project called Refusion, this is a hobby project created by Seth. And heck, okay, what they have done is that they fine-tuned a Stable Diffusion AI model. So Stable Diffusion was an AI model. Given some text, it can generate an image. What they have done is that they have fine-tuned that model to generate images of spectrograms like this. Okay, and this spectrogram can be converted to an audio clip, okay, like this. Okay, so that is the idea over here. In this way, you can actually convert from text to audio. Okay, but there are some steps which needs to be done. So let's go to the details over here a little bit. Okay, so, and what they say is that this particular frequency brings in the spectrogram uses the mill scale. Okay, which is a perpetual scale of pictures by listeners. So this is actually a male spectrogram. Okay, so that is the idea over here, and they use torch audio. Okay, so what they are saying is with diffusion models, it is possible to condition their creations not only on a text prompt, but also on other images. You have this image-to-image in diffusion models. Okay, this is incredibly useful for modifying sounds while preserving the structure of the original clip you like, so you can control how much to deviate from the original clip and towards a new prompt using the denoising strength parameter. So here is the example. So here's that particular funky sax riff, okay, which they have modified it to and they have cranked up the piano. Okay, so here is this particular sound. Okay, here is the same sound that they have modified at the rank of the piano. Okay, another example is given over here. Okay, so now if you have an original image, write this of a particular sound, right? And using the Text Pro, you can actually convert or put emphasis on certain part of this image while maintaining the structure of the original sound. Okay, that is the idea of here, and you get the modified sound. Okay, the next task is how do you loop this? This is a short clip, right? How do you loop this to create infinite AI generator jams? So what they do is that they wanted to generate 100 clips with varying seeds. Okay, but you cannot just concatenate because each of these clips will vary, right? We put in a prompt and generate 100 clips. Each of them will be different. So what is their strategy is pick one initial image, generate variations of it by running image-to-image generations with different seed and prompts. Okay, this preserves the key properties of the clips to make them loopable. We also create initial images that are an exact number of measures. So this is the idea. You have your input image, you have image-to-image, and Stable Diffusion. You create US based on a seed, a new prompt. You create seed images based on this. Now you can actually transition between the clips, but what this is, it is still too abrupt to transition between clips. Multiple interpretation of the same prompt with the same overall structure can still vary. Okay, so what do is that they smoothly interpolate between prompts and seeds in the latent space of the model. Okay, so in diffusion models, the latent space is a feature vector that embeds the entire possible space, what the model can generate. So they go into the latent space of this representation and that they do some interpolation, okay? So items which resemble each other are close in the latent space, and every numerical value of the latent space decodes to a viable output. So what they are saying is that you do interpolation in the latent space. In that way, you can get a smooth loop. Okay, so it is possible to sample the latent space between a prompt with two different seats or two different prompts with the same C. So that is the idea which they have given her here is an example. So what they do over here is that they do the same thing with this audio model to produce battery smooth transitions. So you have a seed. Then they do some interpolation on the latent space of this seed, okay, which is what you get this intermediate images. And then you get this seed B, which is then this thing. So in this way, which is then based on the new prompt. So in this way, they can actually create loops. Okay, so that is the idea over here. So here they are saying about 20-step interpolation. They have given some examples typing to jazz. So this is you are typing and slowly transitions into jazz music. Okay, here you have church bells to electronic beats. Okay, how it transitions. So these are some examples, okay? So the Hugging Phase diffuser's library has a wide range of pipelines, image to image, and prompt. They have used, but we needed an implementation for interpolation, so we implemented this pipeline along with the support over here, right? Masking to limit generation, only parts of the image. So that is what they have done over here. So this is the key idea they also have in web app, which is interactive, where you can actually try out something so you can play that. And probably here I can say that some kind of music. I don't know what is the music which is going to get generated currently. It is generating this part over here. Then it will do this part, music. Let's see what happens, music. Right? Maybe I'll move it to flute music. I have no idea what happens, what kind of music gets generated. It is picked up one of the tunes of your ramen over here, actually of a song. Let's see if it transitions over here, music foreign, music. Music, quite interesting work, right? So let me stop this. So this was about Refusion. The idea over here is that you can convert audio into spectrograms, and from spectrograms you can generate music, okay? So you can use diffusion image to actually transition from one prompt to the next prompt. You can produce this interpolation on the latent space over here of the images of the audio spectrograms to get that smooth effect of, in the music instead of abrupt transitions. Okay, so that is quite an interesting work, an interesting approach over here. They also have their code on GitHub. You can actually go and try out that. Okay, they also have a model checkpoint on Hugging Space. Some people have already created spaces using this particular model. You can try out these spaces. This work is quite interesting. I like this idea of multimodality in the sense that converting the audio to an image, doing something on the image space, and then going back to audio for your necessary, what you call given a text prompt, getting this audio image and then taking it to music, right? Or converting it into audio. So I like this idea of Refusion. So you can go and check out this particular project. You can check out their GitHub page as well. You can give a star to them. You can try out the models over here. I hope this short video on Refusion is useful for you. If you like the video, please like, share, subscribe to the channel.